Okay, our last few sample problems kind of move away from experimental methods to calculate delta H, so this concept of heat capacity, and move on to what we call empirical methods or calculation methods for determining delta H. So the first problem deals with what we call Hess's Law, and that's basically looking at manipulating existing thermochemical equations to give you a final thermochemical equation. So this problem is actually pretty straightforward. There's not a lot of equations that are given. There's not a lot of manipulating that we need to do. So I'll encourage you to practice more problems. The homework problems have several that are a little bit more complicated, but I'm going to walk through the nuts and bolts of kind of what you need to do to use Hess's Law. So again, times that you'll use Hess's Law is you'll have an enthalpy of a reaction that's unknown. So your reaction is given here, and then you'll be given a series of equations that you can use to calculate delta H from. And the concept is that we want to manipulate these equations such that when we add them up, they give us our overall equation. So let me tell you kind of an easy way to go about doing this. Look at your target equation and see things that are either products or reactants. Now look at your given equations and see whether they're set up with things on the right side. Carbon monoxide gas. I want that as a reactant. I have an equation that gives it as a reactant. Carbon dioxide I want as a product. This one gives it as a product. So this one looks like it's going to be good as is. My next equation shows nitrogen gas on the left. I see nitrogen gas on the right here. Oxygen gas on the left. I don't see oxygen gas. NO on the right. I want it on the left. It should be obvious that this is a reaction I need to flip. At the very least, I need to flip it because I don't have my species on the right side. But I also notice that I only want a half mole of nitrogen gas on my right, and I have a whole mole over here. So I also see that I want to flip this down and flip it and scale it down by 1/2. So doing Hess's Law and manipulating equations in some ways is not unlike balancing equations. You might kind of make a first guess as to what you think you need to do. You'll change your coefficients, and then you kind of go back and recheck everything and see if it makes sense. The same is going to kind of be true here. So what I want to instruct you and encourage you to do as you do these problems, kind of look at your target equations and kind of write down whether they're good as is. Do you need to flip it? Do you need to scale it up or down? Kind of look at these and take a first approximation of what you need to do, and then rewrite your equations and see if they sum up to what you need. So I'm going to go ahead and rewrite these equations. The first one I'm going to keep as is. And because I didn't manipulate the equation, my enthalpy is going to stay the same. Okay, my next equation, I need to manipulate it. Okay, so I'm going to flip it, and I'm going to scale it down by 1/2. So this is where you just kind of have to make sure you're keeping track of stuff, not moving quickly, not getting distracted. So flipping it means NO now becomes a reactant, and I'm going to scale the coefficients down by 1/2. So I've got NO making 1/2 N2, and then 1/2 O2. Okay, so I flipped and scaled down my equation by 1/2, which means I need to flip and scale down my delta H. So I'm going to call this delta HB new, meaning that it's a new version of the same equation. And what that means I need to do is I need to flip it and scale it down by 1/2 of what the original value was. So my delta HB new is now going to be minus 90.3 kilojoules. At this point, go ahead and see if your equation sums to what your target is. I can see that I've got 1/2 O2 on the left and 1/2 O2 on the right. Those are going to cancel. Just eyeballing this, CO plus NO, that's what I want. CO2 and 1/2 N2. That's what I want. So things look good. So I'm going to rewrite my target equation, which is the sum. I shouldn't say rewrite my target equation. I'm writing the sum of this, which happens to be equal to my target equation. And now my delta H of reaction is going to be equal to delta HA plus delta HB new. And so when I sum these, I get minus 373.3 kilojoules. So pretty straightforward. Like I said, this is a fairly simple Hess's Law problem. Also, with some of the problems, don't assume that you have to use every equation that's there. It's just a laundry list of equations that you could use. Some of the homework problems, again, have more equations, require more manipulations. Also go through, there's several Hess's Law problems on the Chapter 5 and 6 review sheet that we worked on in class.